Hi, this is Mrs. Moret with a quick video about the parent functions of y equals the sine of x and y equals the cosine of x. So in the last couple of weeks, you've been learning about the unit circle and how to use the unit circle. And what we figured out over time was that each point on the unit circle represents the cosine and the sine of that particular angle. So what we're going to do now is we're going to say, okay, we're going to graph this function so that the x value in this function is going to actually be the angle. And notice that both in the unit circle and on the x-axis of these graphs, the values are given in radians. And so if x is going to represent a particular angle around the unit circle, then y is going to either be the sine or the cosine of that angle. So I'm going to do y equals the sine of x in the top graph, and y equals the cosine of x in the bottom graph. And I'm going to graph each function from negative 2 pi up to 2 pi. But I'm just going to do the right side, so from 0 to 2 pi first. So I notice that on the unit circle, the largest value is positive 1, and the smallest value is negative 1. So I'm going to say that this is equal to 1 here and negative 1 down here. So let's label my axes, 1 and negative 1. All right. So to start with, we'll look at the sine of x. So sine is the y coordinate. So it goes 0, 1/2, root 2 over 2, root 3 over 2, then 1, and then it comes back down to 0. And then it goes into the negatives all the way to negative 1, and then back up to 0 again. So I'm going to put those points onto the graph. So I'm not going to put every single point onto the graph, though. I'm going to put the ones that I really know how to find. So at a measurement of 0 degrees or 0 radians, the sine is 0. So that means there's going to be a point right there at 0, 0. And then moving up to half of pi or pi over 2, the sine of that is 1. So there's a point up here at 1. And then at pi, the sine is 0 again. And at 3 pi over 2, the sine is equal to negative 1. And all the way back to 2 pi, the sine is equal to 0. So I'm not really sure how to connect these points. Some of these values are a little tricky to figure out, but I'm going to kind of estimate the 1/4 of pi using my calculator. So when I do the square root of 2 divided by 2, I get 0.707. So right in the middle of 0 and pi over 2 would be where I'm going to put this point. And so 0.7 is going to be, about here, let's say. And then it happens again at 3/4 of pi or 3 pi over 4. And then it happens again at negative 5/4 pi, only this time on the negative side. And then one more time here. So what this looks like all together is actually a pretty smooth curve like that. And it would keep repeating that pattern. If you can think about continuously going around and around the circle, it's going to complete that pattern continue. So going in the negative direction, so if we were going to go to the negative angles around the circle, so from 0 to negative 2 pi in that direction, we would still have a point at 0, 0, so here. And then at negative pi over 2, well, this is where you would find negative pi over 2. So we're going that way. We're down at negative 1, so here. And then continuing to negative pi, we're at 0 for sine. And then to negative 3/2 pi, we're up at 1. And then again, all the way to negative 2 pi, back to 0. And then those in-between points are still there. You can see them here and that one as well. And so we have these like about 0.7 in between those places. And so we have this, this same sort of pattern going this way. And that would also repeat. And so when you look at like a computer generated sine or cosine graph, it obviously will look much better than mine, but you get the basic idea of how this is a function that repeats over and over. And the name for that type of a function is periodic. And so sine and cosine, and even tangent, which you'll get to eventually, functions are called periodic functions. So let's look then at the cosine. And so I'm going to erase what we were looking at over here so we can focus on the cosine of each of those angles going around the unit circle. And so in a similar fashion, we can look at the x values of each of these points. So again, in our function, x is going to represent the angle, and then y is going to represent the cosine of that angle. So here are all of our cosine values going around the unit circle. So I'll do the same thing in that I'll start at the cosine of 0. Well, the cosine of 0 is actually 1. So this is a point up here. And then the cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi, so all the way around the circle, the cosine is 1. And then notice that in the middle of each of these quadrants, we have that root 2 over 2, that halfway value. So halfway between 0 and pi over 2, there's a point at about, that's a little bit low, at about 0.7. And then same thing down here at about negative 0.7. And it happens over there as well, and then about here. So this is called one period of this cosine graph, and it would continue to repeat in that manner. So they look very similar, only if you look at when x is 0, they start in different places. So then looking at the negative side of this, so if we go back to starting at 0 and going in the negative direction like that, we still have, well, the cosine of 0 is 1. The cosine of negative pi over 2 is 0. And then the cosine continuing up to pi, the cosine is negative 1 at pi. And then up here to negative 3/2 pi, the cosine is 0 again. And then all the way around the circle, negative 2 pi, the cosine is equal to 1. And same idea, once again, those little points in the middle at root 2 over 2 and negative root 2 over 2. And I'm just kind of estimating where that would be. And so we get another period of the cosine graph. So these are the parent functions of y equals the sine of x and y equals the cosine of x.